guys, and lastly, we're looking at 1.6, which is something called biconditionals. So inside your vocabulary that you saw at the front, it says when a conditional and a converse are both true, you can combine to create something called a biconditional statement. So what that means is that you're basically creating a definition that can work both ways. No matter how you write it, it's always going to be true. So let's go and look at this statement real quick. So I have a conditional statement that says, if you are a rocket, then you go to Robinson. Okay? So let's go ahead and flip that and make it the converse. If you go to Robinson, then you are a rocket. So in my book, both of these are going to be true. So the truth value of both of these are going to be true. So remember, if both the conditional statement and the converse are true, then that creates a biconditional. So now I can rewrite both of these statements into a biconditional. And the way I do that is I drop the if and then in the middle put if and only if. So let's go ahead and write this. So right here, you're going to put, you are a rocket. Remember, I dropped the if, so if is gone. I'm taking that out. You are a rocket if and only if you go to Robinson. You go to Robinson. So if you notice, there's no then in there. So right there, you are a rocket if and only if you go to Robinson. So remember, if we have a biconditional, I'm going to drop the if and then, I'm going to put in if and only if, and that creates a good definition. Alright guys, so let's go and look at example number 1. So right now we have a conditional statement that states if 3 points are collinear, then they lie on the same line. So right now, obviously the truth value of that is going to be true, because if you have 3 points on the same line, they're automatically collinear. So right there, that is true. So now let's go ahead and write the converse. So I'm going to take the hypothesis and the conclusion, and I'm going to switch those. So right now I'm going to put if, and actually we need to put it like this. If 3 points lie on the same line, then they are collinear. That's how we should write this. So if 3 points lie on the same line, then they are collinear. So now that's going to be the converse. I swapped the hypothesis and conclusion. So right now, that is basically saying the same thing. If 3 points lie on the same line, then they are collinear. So the truth value of this statement is going to be true. So remember, if the conditional statement and the converse are both true, that makes a biconditional. So that means we can take one of these sentences and turn it into a biconditional. So with a biconditional, I'm going to drop the if and then, and I'm going to put if and only if. So right here, we're going to do the top one. So 3 points are collinear if and only if and only if they lie on the same line. So we have just now created a definition. So instead of writing it as a conditional or converse, we can just create a demanding definition saying 3 points are collinear if and only if they lie on the same line. Alright guys, now on example number 2, it's wanting us to work backwards. So it's given us a biconditional, and it wants us to write the conditional and converse so we get a better understanding of how this works. So basically remember, if I have a biconditional, I'm going to take the conditional, drop if and then, and put if and only if. So now I'm going to do it backwards. So I'm going to drop if and only if, and put in if and then. Okay? So here we go. So a number is divisible by 10 if and only if the last digit is 0. So I told you if we're going to do the conditional, I'm going to drop the if and only if, and I'm going to put in if and then. So I'm going to put if a number is divisible by 10, then the last digit is 0. So that is going to be your conditional because I put the if and then in there. Okay? And so now I'm going to make the converse by switching the hypothesis and the conclusion. Hypothesis comes after the if, conclusion comes after the then, so I'm going to switch those. So now I'm going to put if the last digit of a number is 0, then it's divisible by 10. So right there, ladies and gentlemen, we can see I just created the conditional and the converse out of this, and both of those are true, which then makes a biconditional in return. Alright, lastly on example number 3, I'm just going to talk through these real quick, and it wants us to determine if this is going to be a good definition or not. And the way we do that is we're going to think of it as a conditional, then make its converse and see if it works out both ways. Then it's going to determine if it's a biconditional. So let's go and look at this first one. A segment is a part of the line. So let's go and think of the conditional statement. So if I have a segment, then it is part of a line. So that's true. I would work with a conditional. So let's go and flip it. So if you have a part of a line, then it is a segment. So the inverse, or the converse and the conditional would both be true. So then that would make it a biconditional. So then this is going to be a good definition. So on this one, it just wants you to tell if it's a good definition. So we're going to put on A, we're going to put good, because it is a good definition. So let's go ahead and check and see if B is going to work out for us. So a cat is an animal with whiskers. So let's see if this is a good definition. So first, let's go ahead and change it into a conditional. So if a cat is an animal, then it has whiskers. Okay, that's true. So let's flip it. So if the animal has whiskers, then it is a cat. Well, a cat isn't the only animal that has whiskers. You have walrus, you have seals, they have whiskers. Other animals have whiskers instead of cats. So that is not going to be a good definition. So the second one we're going to put not good, because it is a not good definition. So right now I showed you that if you have a biconditional statement, meaning the conditional and the converse are true, then it makes a good definition.